Hello and welcome on my channel. If you're interested in different cyber defense techniques and you want to know what's the difference between SAST, DAST, IAST and RASP, then you're exactly right here. By the way, my name is Van Ruppert, I'm developer advocate at JFrog, and if you're interested in topics like Java, Kotlin or cybersecurity, then you're exactly right here in my channel. If you're the first time here, welcome on my channel. I really would appreciate to see you as my new subscriber, and if you like this video, thumbs up, subscribe my channel and turn the bell on so that you don't miss any new video. Okay, so far I would say we will start now. Before we are looking at these four main defense groups or cyber defense groups, I want to highlight a little bit what happened in the near past, and this was based on the SolarWinds hack. So I don't want to go into all details of the SolarWinds hack, just a lesson learned, because what we saw is that the attacks are now not against the final target or just production systems. The attacks are now against the whole supply chain. It means they are searching for multiplayers, they are searching for weak points in your production pipeline so that they are able to modify it so that you are building compromised binaries, that you are distributing it. And this whole shift to attacks against the supply chain is something that pushed us or forced us to scan not only our production systems or secure our production systems. It's important for us now to secure everything. So it means our production system, the network infrastructure, the whole CI environment where we are building stuff, our IDEs, the dependencies, so everything that's involved, because everything could be compromised, everything could be used as an attack vector. And we have now two dimensions I want to highlight here to show why this overall picture is very important for all of us in the software industry. Okay, what are the main things? So if someone is asking me, say, what is the main thing, or if I'm discussing with someone about cybersecurity risk, where you should start, the first thing everybody is aware of is, I don't want to consume compromised binaries. What are the places for possible corrupted binaries? Well, it's inside the operating system, inside your infrastructure. It could be the CI build system. It could be the dependency you are declaring in your development environment, like Maven or whatever, so that you're grabbing dependencies. So this is by far the biggest part of the whole tech stack. Even a Docker file will start with a from statement. But the main thing is here that you're not only focusing on consuming binaries in your runtime environment, you should include the whole production line as well. So it means your IDE can be compromised, your compiler can be compromised, your network infrastructure can be compromised. So everything is part of you are consuming binaries. But as a software developer, we are not only consuming binaries, we are producing binaries as well. As I mentioned, we are not only consuming binaries, so for dependencies or operating system or whatever, but we are producing binaries as well. So if we are producing a microservice, we are producing a product, we are producing a function that we are deploying. So now we have two different targets. So it could be for our own system. So we are pushing compromised binaries to our own production environment. This is not good. And the other side is we are delivering something to customers. So we are delivering an app, we are delivering a microservice, whatever. And this is pushed to the customer and will be used on the customer side. So even this is worse, because who will trust your environment or your binaries if this happened once? So the economy damage you will have is sometimes really, really critical. So, and this happened with SolarWinds. So what happened there? The hacker group compromised the CI environment with every build. SolarWinds built a compromised version of their Orion platform, this network management software. This was distributed automatically to, I think, 15 or 20,000 customers. And, well, what should you do? So who will trust this company? So what is the effect? What's the financial impact for this company? So you as a software developer, you have now two paths that are critical for you. First of all, grabbing compromised binaries, and the second thing is distributing compromised binaries. And both paths are not nice. And we will have a look now at what are the different main techniques you have to fight against these non-vulnerabilities as well as 0 days issues. Okay, let's talk about the first group of cyber defense techniques what we have, and this is called SAST, Static Application Security Testing. And this word implies it already, so we are scanning the static part of an application. So it means all the stuff you can extract in static semantics, that's part of the static semantic, can be extracted and tested. SAST is something that is used to scan against known vulnerabilities in your dependencies as well as compliance issues. So security is not only securing against vulnerabilities, it's securing against licenses that are in the wrong place of your supply chain. Even this could be a big damage for your company. But focusing on vulnerability, so SAST needs access to all components, then you can scan them and you will see that a dependency will have a vulnerability, a known vulnerability, and then you can decide if you want to go with a version once up or once down. And this is mostly the effect you have. So scanning against known vulnerabilities, and this implies that you have a very good dependency management, efficient dependency management, so that you can build a composition of versions of your dependencies with a minimum amount of known vulnerabilities. So this is more or less the basic idea of SAST, so this static application security testing. And here we are constantly focusing on known vulnerabilities and compliance issues. Okay, coming to the pros and cons of SAST. First of all, a big plus point is with SAST you can scan 100% of your tech stack, because everything that you have in a static way you can scan immediately. So your operating system and so on. This is a big plus. A minus is that you can scan... No, nochmal. What are the pros and cons of SAST? So one big plus point is that with SAST you can scan 100% of your system. This means really all dependencies, transitive dependencies, all runtime environments in terms of binaries you can scan. A negative point is on SAST that you can just scan the static context. You have no information about the dynamic behavior of the application, the dynamic context of this application. It means it makes no sense to scan configurations or assume that there is some misuse. You're just focusing on the static part. The plus is that with SAST you can start immediately. So even if you're just starting with your project, you can start scanning against known vulnerabilities. With the first line you're adding a dependency, you can use SAST. It means you don't have to work some time, or you don't have to make something running. You really can start immediately. Not only inside the CI environment, you can even start inside your IDE with SAST, with the Static Application Security Testing. By the way, if you want to know how to do this one, I have workshops at JFrog to show how you can start inside your IDE with Static Application Security Testing. And on the other side, you can check out my YouTube channel. I have some how-tos, how to start and how it looks like. So if you want to use the free tier and the IDE plugin from JFrog. Okay, what are the other plus and minus points of SAST? So one thing is, one very good plus point is that you can scan against compliance issues. No other technique is able to scan against compliance issues, and this is a risk for the company as well. So what are the other plus and minus? Oh yeah, very good is that SAST is very predictable in runtime. So in the time, in the duration you need to scan your system. So you have an amount of dependencies, you know how long it will take to scan them, and this will not change. So there is no exponential growth. So a double amount of dependencies means normally just double amount of scanning. Other techniques have exponential growing. So this is a plus point for SAST. Overall, yeah, SAST is something that is very early in your production line until it's running in production. So everything that is not running, everything that is static can be scanned, and you can start very early with this. So these are the plus and minus points of SAST. And yeah, let's see how to capture the dynamic part. We spoke about the static application security testing, and the opposite is dynamic application security testing. So now we're focusing on the dynamic part, and for this what you need is a running application, and then this running application will be attacked from the machine. So it's a hacker approach. So you try to compromise the system from outside. So you don't need knowledge about the technology or whatever. You just have this application that's running, and then you try to break in or to compromise it. Mostly it's based on the most common vulnerabilities, so SQL injection and heap memory dumps and buffer overflows and whatever you try to do. And this composition of most common vulnerabilities you can check out. There are several references in the internet. I will highlight maybe the URL to this organization that is collecting the most common vulnerabilities for web applications. So in general, it means this dynamic application security testing is focusing on hacking or compromising active running systems. For this you need an active running system, and you can scan the whole environment, so all the dynamic behavior, so open ports and SQL injection and so on and so on. So this is more or less a dynamic application security testing. And what are the pros and cons of it? Okay, what are the pros and cons of DAST? DAST itself is focusing on the dynamic application security, or the dynamic part, the dynamic context of an application. So a good point is that you can identify weak configurations, for example, because you identify open ports and all this stuff. This is not possible with SAST. On this, and additionally to this, you're scanning the boundaries from outside. So you don't need access to the components of this application. You don't need access or knowledge about the technologies that are used. You're just focusing on the services that are available and try to attack this one. This is a pro and a con at the same time. So a pro is that you don't need the knowledge about the technology that is used to implement this service. On the other side, you are never able to scan 100% of all components with DAST, because you're just focusing on the available functionality from outside. You're scanning this directly and indirectly, partially the system, but you are never able to scan really 100% of all parts of the application. So on the other side, with DAST, you need something that's already running, and this implies something you have invested already some time. So you are able to find dynamic, or you are able to find unknown vulnerabilities, but the price is that you just start scanning after you have all the work done. So it's very late in your production line or inside your supply chain. So you invested already something. So getting rid of vulnerabilities found by DAST is very expensive compared to SAST, because you are redoing all the work. Another thing that is not nice with DAST is that DAST will have an exponential execution time. Means if you have the double amount of functions, you mostly end up with a quarter or whatever amount of time to scan this functionality. So you have exponential execution time compared to SAST. SAST is just a linear increase of execution time. So yeah, so you have pros and cons with DAST. The good thing is that you can do it from one thing that's very important is it makes just sense to use DAST against systems that are exactly like production. So it makes no sense to have this DAST approach against test systems, because the full potential of DAST can just be hold or get if you're really testing against production, so that you have the final configuration, the final power of the system. So all tests that are going over try to overheat or to overuse the service to have some attacks. This is not possible if you're just doing it with some kind of test environment that's not the same behavior like the production system. On the other side, a very good plus point is, if you're running DAST application against a production system and it holds, then it's a good safety belt against all these dynamic and most common vulnerabilities at this part. There is an organization that will highlight what are the most common vulnerabilities for the DAST part. I will try to write here somewhere the URL to this organization so that you can read about it. And one point that's not so nice with these DAST tools is they're using machine learning, artificial intelligence or whatever, so to increase from the known vulnerabilities like SQL injection to zero-day issues in a way that they try to combine different techniques to new attack vectors. But if you want to customize a DAST tool, you need a very, very good knowledge about the attack vector itself, because you have to train the system so that the system is able to attack exactly with this attack vector your production system. So it means using DAST is good. If you really want to get the best out of this, you need very specific knowledge and the possibility to customize your tool so that you are able to customize different attack vectors. So we have static, we have dynamic part. What is the evolution? So what is the next step? We saw the one side is a static application security testing. We saw the opposite. So the other side is a pure dynamic application security testing. So what's the evolution of this one and what's the lesson learned? So the next step is that they try to merge both, so the static and the dynamic part, and this is a IAST, this interactive application security testing. So the three components are the static analysis, the dynamic analysis, and the interactive part. So this approach is mostly focusing, or they're implemented with an agent. So an agent will deliver it with a production system or with a system you want to test in the dynamic area. And this is changing like an agent, the production system, so that you can extract metrics like data control, what data is used, what are the metrics, CPU utilization, whatever. So all these metrics you want to have to check if there's something. And on the other side, with this approach, if you're not just testing as a black box test from outside the production system, means that you want to combine, or you can use it more or less inside your CI environment or partially inside your IDE. Because you have all this, not only the static one, the dynamic part, and the interactive one. So you are able to use this tool to manually compromise the system. So, but what are the pros and cons of this merge? So, what are the pros and cons of this interactive application security testing? So first of all, a good plus point is that we try to merge the static and the dynamic part. This is a definitely good approach. Good is that with interactive application security testing, we try to shift this dynamic part more and more left, so that we are using it inside the CI environment or even inside the IDE. A challenge here is to identify things that are inside the test system but not in the production system, or reverse, because you are dealing with different environments. The plus point here is that we start using interactive approaches as well. So the pure dynamic application security testing tools, mostly they have their amount of attacks they're using. Then maybe they have some fuzzy technology or some machine learning stuff, but it's not so easy and not so detailed. It's not possible to change it very detailed. All these tools are very complex, so that you need all the knowledge about the attack vector by yourself. And the same with the interactive application security testing. So it's not easy to simulate an attack if you're not really a pro in this area and you really have this deep knowledge. On the other side, what's really good with interactive application security testing, that you have access to the static and the dynamic part as well. So the combination of both inputs or both information pools are very, very good, because now you're not only looking on the outside, you have the knowledge about the technology, you can focus for this technology specialized attack vector against the system, and so on. So this is a good thing. The interactive part is something new. This is good, but I assume it's for the most developers, it's not so easy to really have a very qualified attack. On the other side, what's the bad point? The bad point is the implementation, or how to get all these metrics, is done by an agent. So you will start an agent. This agent is able to modify the application to extract data. It's like performance measuring. So you're collecting data, you are collecting environment metrics, and so on. Good at one point, bad because good at one point, but bad on the other side, because you have a trade-off in terms of performance. If I got the information right from different vendors, they are talking about something like 1 to 4% trade-off of performance. And this is for some environments just too much, or just too expensive. And Yeah, well, so this is good on the other side. So it's good that you're merging both. It's bad that you have this agent approach, because this agent approach, this could be really the worst case. So imagine that the company that is providing this agent will be hacked like SolarWinds. Then you will have a compromised binary, an agent that you will give the full control about the application, including the possibility to change the application dynamically. And this would be a worst case scenario. So yeah, there's one thing. Sometimes you have environments where agents are just not allowed. So then you can't use this approach for the production environment. You can just use it inside your CI environment and so on. And have in mind that if you're using on one side an agent modified thing and on the other side the pure thing, this is not equal. So it's not exactly the same, and it could be lead to different behavior of the applications with or without the agent. And we need more research on this one. So I personally think that the interactive application security testing is the way to go over the long run, because we are merging all these different approaches. So far, the tooling is not good enough that you can just fire and forget this tool stack. You need some special knowledge. And if you want to start with security, maybe this is a too complex approach in the beginning. Okay, we saw the static part, the dynamic part, and they try to merge both of these approaches with this interactive security application testing. And what's in common of all this is that they try to identify known or unknown vulnerabilities, to identify these weak points inside your system. And the next approach is that you completely try to identify a different angle of these attacks, and this is RASP, this Runtime Application Self-Protection. And it means here we are focusing not on known vulnerabilities or dependencies or whatever. Here we are just analyzing the behavior and the data that is shared with the application. So what data is coming in, what is the behavior of this user. So really on a session and user base, they try to identify, or between sessions and users, they try to identify stuff that is not right. So if someone tried to hack in the system, if someone tried to compromise the system. And we have now two versions, or we have two modifications of this. Is the first one is that you just try to find and alert. So just identify in real time there is something alerted, and that's it. And the other approach is that you even allow this application to shut down independently. So, okay, there is a session, this looks a little bit dangerous, we are blocking this session, or we are blocking exactly complete this service. And for the future it's planned, sometime it's available, but for the future it's planned that even the self-healing process is dynamically done at the runtime system. So there is something, it will be identified, this is a weak point, and then it tried to find a solution so that it could not used in this compromised way anymore. But this is more future, so there's the self-healing stuff. But in general, you have now running inside the application, try to identify what data is coming in and try to find out what action is the right one, what's not the right one, and try to do all this in real time. What are the pros and cons of RASP? One very good thing is that with RASP you are identifying completely new approaches to compromise your system. So it's really analyzing what's coming in, what is the behavior, what is the temporal aspect, and all this stuff, and this in real time. So a human is not able to analyze and react so fast at this approach, definitely not. The disadvantage is you can just use it in production, and it makes just no sense to use it in your CI environment or inside your IDE, because then you have to do all these interactions, then you know already what kind of attacks you want to try, and there is no benefit. So it means if you know what you want to do, then you can just eliminate it in your code way earlier, so you don't need RASP for it. On the other side, the knowledge about what's going on and this matrix you will get out of it is very, very good for many things in your application. Bad thing is, again, you're using an agent, so an agent must be able to modify this one. So if you're just monitoring it, then you have just a good idea, now something is happening, but then you have to interact. If you really want to have this possibility to react immediately, you need this approach of service will be blocked dynamically by this application. So this is good. Then the service is blocked, so you have no attack so far, but you have the need to do something. So if you really will get this approach of a self-healing and self-modification application that will identify this misuse and try to change the application so that this misuse is not possible anymore, this would be perfect. But it will take some time to come to this point. So far we are not here. One weak point is you can use it just inside your production environment, and it's again an agent approach. So you will have this trade-off of performance. You need additionally CPU cycles to identify, to do all this learning stuff in real time. Otherwise this is just wasteless. It's just waste, because then if you're analyzing offline later, then it's too late. So it makes no sense to use RASP for this one. Then regular logging is enough. But this approach is cool. You need additional power to do it. You need it in real time. You need fast and responsive networks and interactions and a fully automated environment so that you're automatically able to block services. In some environments, again, this is not allowed, because then you have something that can modify the system or can do stuff in your application or in your production environment. And have in mind, if the company that's providing this agent will be compromised, like SolarWinds was compromised, then again, this is just pure pain. So this is really the worst case. So in general, I personally think this approach is a very cool one. And the bad thing is that developers that are using, or operating systems that are using this one, they are so in this kind of trust. So yeah, even if I'm missing something, this will get it. And this is not good. So you have really to work against this behavior if you're using RASP. But RASP is a very cool addition. So this is RASP. We saw different approaches. We started with SAST, Static Application Security Testing, and this is focusing on all dependencies. You can scan against known vulnerabilities and compliance issues. And this is a very fast implemented technology without any needs for the runtime environment. So this is the only approach to scan really 100% of the whole tech stack or the whole supply chain. And based on the lesson learned from the SolarWinds hack, this should be at least the minimum step you should do if you start with security, or if you have some kind of security implemented. You should focus on SAST anyway. The next part was the dynamic part, so really just looking from outside against this running application and try to hack it with the most common vulnerabilities. So this approach is a good add-on, but it means that you need a running application so far. SAST you can start immediately. DAST it's just able to do, you're just able to do it if you have already a running thing, and you're focusing on the most common vulnerabilities. Quite often this tool stack is not so easy customizable. So if you want to train your DAST environment for new approaches or new attack vectors, you need specific knowledge about how this attack vector is and how to implement it. And then mostly this tool stack is not really prepared for adding new attack vectors, or they're quite complex. The lesson learned of SAST and DAST was that we start merging it to IAST as interactive application security testing. So it's how the component of static application security testing, dynamic application security testing, and interactive security testing. By the way, my personal view on interactive application security testing is a little bit tricky, because you need a bunch of knowledge how to do this one. But the good with this is you have now the possibility to shift it more left, so even the dynamic part. And during the part of this dynamic application security testing, you have the full access to all components. So you can combine metrics and you have way more information about the overall system at all. The next thing is, after IAST, is a self-healing process. That's runtime application self-healing process. Means that with RASP, you try to analyze the behavior of the stack. So what data is coming in, what use cases are used, what is a combination between sessions, and all this stuff. For this, you need additional resources for this real-time analysis. This is purely focusing on unknown vulnerabilities and active cyber attacks. And this just makes sense on production systems. So with RASP, you will find nothing new inside your development environment or your staging environment or your development environment, your IDE, because RASP is really focusing on this attack is happening now. It will give an alert, or if you allow, it will block the service automatically. And this is a big difference between all this previous one. All the previous, so SAST, DAST and IAST, are focusing on known vulnerabilities, maybe a little bit on new vulnerabilities, but RASP is really just focusing on identifying active happening attacks against your system. So this is a good approach. On the other side, make sure that your developers are not lazy. So like, oh, if I'm missing something, RASP will catch it. No, that's not the case. That's not a good approach. You have to work against this behavior. On the other side, altogether is a very, very broad topic. If you ask me what I should focus on if you start with security, I personally would give you always advice, start with SAST, because then you have the full stack tested against known vulnerabilities, and the statistics say that the amount of known vulnerabilities are way bigger than the unknown vulnerabilities. You can scan in the same time against compliance issues. This is sometimes poison for your business as well, so it makes sense to check this one as well. And you can do it even inside your IDE. So with SAST you have the biggest shift left possible. On the other side, what's the next approach? If you have SAST really implemented, the next step could be IAST, as interactive application security testing, because it's adding the dynamic component, but in the more shift left version compared to DAST. On the other side, you have immediately this agent approach if you want to have it on production as well, and you have to check if this is even allowed in your system, and you have to trust the provider of this agent. And the last step would be really building the defense wall with RASP, so that you're able to identify active attacks and can start working against it. So my personal advice, start with SAST, go over IAST, and the last thing, the fine-tuned thing, is RASP. So that's it. So, well, I hope you enjoyed it. If you are interested in more topics like this, let me know inside the comments. So write down what's your experience, what tools you're using, what is your way of thinking about these different approaches. I really would like to see what is on your side to learn and to start a discussion with you. If you want to have a discussion with me, well, social media, LinkedIn, whatever suits best to you, or just a comment here in this video, this would be awesome. If you are new to my channel, please subscribe my channel if you like it. This is the way to say thank you to me, and additionally a thumbs up if you like it, so that everybody knows it and it will be recommended to others. And well, that's more or less. Whatever time you're looking at this one, I hope you had a good time. I hope you enjoyed it, and have a good rest of the day, whatever it means. And well, my day is more or less done. I will start eating a little bit, then I will explore a little bit this part of the forest, because this one is a new one. Then I will go home late. My day is more or less done, and I would say thank you very much for watching. Stay safe. See you soon here on my channel, and enjoy the rest of the day. See you.